be here today and talk with all of you. I'm going to talk about what is arguably the most commonly reported risk to mining companies as we start thinking about this global energy future, and that is water stress. I'm Kamini Singha. I'm a professor of hydrogeology here at the Colorado School of Mines, and I've been working on issues of water resources for 20 plus years. But that is no time at all when you think about how long people have been thinking about the connections between water and energy and mining. This image I'm showing you here is 140 years old, showing a miner using what I hope to argue to you is his most valuable resource to extract resources, and that is water. So the punchline of my talk is this. The energy sector requires billions of cubic meters of water each year to do a myriad of things. So what does a cubic meter look like, and a billion of them at that? The kind of water truck we see driving down the highway takes about 2 cubic meters of water. So in order to make a billion of those, I need to have a truck like this, nose to nose, down the longest highway in the United States, that's I-90, going back and forth 300 times. And that's a single billion. Right now, just in the US alone, about 10% of our water use is going to energy. So what we know is that mining is increasing. In order to get to the raw materials we need to meet energy requirements for the Paris Agreement targets, things for solar photovoltaics and hydrogen fuel cells and wind turbines that we are going to need to mine more. We also know that oil and gas is going to be around for a while. At least the next couple of decades, we're probably looking at similar production levels to right now. So not surprisingly, if oil and gas is staying about the same and mining is going up, this probably means we need more water. And that is true. But where this gets interesting is about the distribution of that water. When we take a look at this map worldwide, what I'm showing you is a map of water stress across the planet. The areas in dark blue are high stress compared to the areas in the lighter colors. Now, water stress is a super interesting term because it looks at demand with respect to supply. So it's not just about how much water is available. We would call that water scarcity. Water stress also incorporates some other things like water quality, how consistent the flows are, and how easily we can move water from one place to another where we need it. So if we take a look at 7 of the most major mining areas worldwide, what we see is a consistent pattern here, and that is that all of them are in areas of high water stress. These 7 areas alone brought in $150 billion in mining revenue in a single year. So we're talking about a problem that is pervasive and important. What's interesting about this is we see water stress even in places where we wouldn't think about it. What I'm showing you here is an image of the European Drought Monitor from the summer of 2018. And what you see is a very dry northern Europe. And this is not a part of the world that we think of as being arid and sort of water short for the most part. What happened in the summer is that KNS mining, which is in Germany, had to shut a couple of potash mines down for a couple of months at the cost of $2 million a day. And this is not the part of the world that we think about. In that last map I showed you, this part of the world is light blue. It's not a big concern. So what we know is that with a changing climate, we're going to see water stress in places that we haven't even predicted it. 92% of companies worldwide said that it could fundamentally change the way that they run their businesses because they don't have enough water to hit what they need. So there are a bunch of solutions to this, one of which is sort of obvious. We could use less water in our industrial processes. It's not surprising if we don't use as much water in some part of the system, there's more water in other parts of the system. But there are other options too. One of them is to think about water recycling. Right now we use potable water for almost everything. And we don't need to use the water that we drink for things like cooling and dust mitigation, for example. And there may be other parts of the system where we could think about water reuse. The other place that we lose water is sort of all along the system. What I'm showing you here are some ponds where we have huge evaporative losses off water. We also think about leaky pipelines where we lose water. We also throw away that wastewater that I was just talking about that we might be able to reuse somewhere in the system. So there's lots of places where we're wasting water where we may not need to. There are some systems where we may need infrastructure, dams, desalination plants, for example. These are not cheap, but they might be needed. I'm going to talk about Chile in just a moment, and the cost to desalinate one of those water trucks we were just talking about is about $10. But when you think about how much water we need for these systems, that adds up really quickly. And that doesn't even account for the energy costs that are in that system, many of which are fueled by coal. And then the other option is to think about securing more water rights. But this can take years of engagement and lead to increased conflict between communities and companies that are there. So this is not an easy solution to a complicated problem. So part of the reason I'm highlighting that there are many solutions is because there's no silver bullet for the shortage of water. And the solutions that we need in each of those systems that we've been talking about is going to change as a function of three major things: the geology of that system, the climate of that system, and the people that are there and their relationship with both the land and the companies that are working there. And because of these three things, it's going to be some combination of things that we need to think about in order to get the best sort of water resource use that we can to meet those global energy needs. I want to talk about two examples in particular. The first one is here in Brazil. This is Rio Gold Mining's site, and they also were dealing with a drought in 2018. And they had a combination of ways of dealing with that, one of which was just sort of waiting the drought out. Reducing their water use was another, and the last was thinking about infrastructure needs. So they shut down this Riacho de Machados gold mine for a couple of months, and this is despite the fact that they had pretty good infrastructure. They had dams and pipelines in place, and it was an expensive issue for them, right? It cost about $5 million a month on that shutdown. So what they did during this time was they, thought about their sort of minimizing the water that they had available. But since that time, they've also put some time and effort into finding additional resources. They've started a water supply well research program in the last few years as a way of building additional resources. One of the things I'm not even talking about today is water quality. There's also big issues with acid rock drainage at this site, which is not surprising in a lot of gold mining-related sites. So there's multiple issues here, but this idea of multiple solutions is a key thing to many of these places. The other place I wanted to talk about was Chile. I mentioned Chile earlier. They're in the middle of a record drought right now that's lasted for about 13 years. And this is causing stress nationwide. So one of the solutions that the mining companies have come up with is to build desalination plants. The idea is to have 15 new plants online in the next 5 years. And the hope of that is that they'll be able to sort of balance freshwater use with seawater use to make those about even. And the idea of moving to desalination plants is to deal with some of the conflicts that are happening right now in the country over water resources. There have been road blockades and hunger strikes because there's such a limited amount of water right now, and it's everybody is trying to get their piece. So the idea of desalination brings new water online, which might address some of those issues. However, there are some really interesting concerns about whether or not this moves conflict downstream, where we end up seeing now issues on the coast because of brine disposal. And a really nice paper last year by Odell talks about some of those issues. So the punchline, the end of this talk is this: no surprise, water is an increasingly important resource to all of us. And there are a myriad of solutions that we need in order to get the water that we need for the global energy future. There are a variety of scientists here and beyond that work on these sorts of problems, but what we have to think about are three major things. We have to think about the geology, the climate, and the people so that we know how to move forward. Thanks.